Question 2, describe destruction bonding in magnesium. So it's a classic question I would recommend memorizing. A giant lattice of Mg2 plus ions. So let's write this down, type this down. Giant lattice of Mg2 plus ions. An electrostatic attraction between Mg2 plus ions and delocalized electrons, and you do have to say delocalized. Say the trend of atomic radius down group 2 from Mg to Ba. Well, it's going to increase as you go down group 2. Increases. Reason being is the number of electron energy levels increases. The number of electron energy levels increases. Given equation for reaction of magnesium with steam. Classic equation. Mg solid plus H2O gas to form magnesium oxide, MgO solid plus H2 gas. One of the observations, bright light. That's an easy one. Or white flame. Bright light. Second observation, white powder. White. Sulfates have different solubilities, they form the least soluble of these sulfates. PSO4, baryonyl X-rays, or antenna organ / baryonyl. 2.5, 2.6, 2.5. Sample is strontium made up of only 3 isotopes, 86, 87, 88. Sample contains 83% by mass of 88 SR. Sample strontium has 87.73 AR. .88 times by 0.83. 87 SR, you can say equals X, therefore 86 SR equals 1 minus 0.83 minus X. 0.17 minus X, so we get 87.73 equals 88 times by 0.83 plus 87 times by X plus 86 bracket 0.17 minus X. Okay. 87.73 equals 73.04 plus 87x. (14.62) minus 86x. 87 minus 86 give me x. So x is equal to x is equal to 0.07. Just add these two together and then do this, subtract that, so 0.07, and that's equal to 7% done by 100. And we want the percentage abundance of each of the other two isotopes in the sample. Well, we know 87 SR is X, so 87 SR is going to be 7%. And 86 SR, well, 86 SR is just going to be, because we know the total must add up to 100, we've got 83% of 88. We now found out that 87 SR 7% is just going to be 1 minus 0.83 minus 0.07, and that will give me 86 SR. So that'll give me 0.10, which is obviously 10%. And then 2.6, magnesium hydroxide uses anticide to treat indigestion. Okay, don't really need to know this as well. Okay, what's the first thing we're going to do? What we're trying to find? We're trying to find the percentage by mass of magnesium hydroxide in the digestion tablet. So we want to find the mass of magnesium hydroxide over the total mass. So find out the moles of HCl, concentration times by volume. Then we can find out the moles of NaOH. Moles of NaOH, because it gives us the concentration and volume. So why not? 29.25 divided by 1000 moles per DM minus cube times by 0.100. So therefore the amount of HCl, because we know the amount of HCl remaining after this reaction is determined by titration with this much of NaOH, we found out the moles of NaOH, therefore the moles of NaOH is the remaining of HCl. 4 moles, because it's titrated with the NaOH, is 2.925 times by 10 to the power minus 3. Now we can find out the moles of magnesium hydroxide, because all we have to do now is do 8 times by 10 to the power minus 3 minus 0.0925. So moles of magnesium hydroxide equals 0.00800 minus 0.00295. That will give me 0.00575 mole. Not mole, sorry. The concentration. But obviously, because it's a 1 to 2 molar ratio, the HCl we need to divide by 2. So divide that by 2. That's why divided by 2 we get 0.0025375 moles. Now we've got the moles. Moles is mass over ml. Mass is going to be moles times by ml, magnesium hydroxide. That will give us the mass as 0.148 divided by the total mass, which is 0.200 grams of the powder tablet, times by 100, and that will give me three consecutive figures 74.0%, and that's the end of question 2.